Let's go back to the Houston Rockets. And to simplify things, let's pretend the only members of the Rockets are Harden, Capella, and Tucker. Now, we need to create a model for our language. We have the terms for point guard, that's P. We have a term for center, that's C. And we have a term for forward, that's F. Then suppose we have one relation in our language. That is to say, we have RXY, and we're thinking about that as X is better at shooting threes than Y. Here's how we're going to set up a model. We have our domain, H, standing for Houston Rockets, and that's going to be the set consisting of Harden, Capella, and Tucker. Then we have our interpretation function. We need to interpret the individual constants here in this middle row, and we need to interpret our predicate letters, and we only have one in this case, that's here on the bottom row. Notice our interpretation function takes us from the word point guard to Harden, from the word center to Capella, from the word forward to Tucker. Now our interpretation of our relation function is going to be the set of ordered pairs such that the first item in the ordered pair is better at shooting threes than the second item in the ordered pair. So Harden is better at shooting threes than Capella, Tucker is better at shooting threes than Capella, and Harden is better at shooting threes than Tucker. Notice order counts greatly when you're using ordered pairs with the square brackets here. Now, this is what it looks like to set up a model. So anytime you're asked to set up a model to interpret a language, these are the things you need. You need a domain, and you need an interpretation function for the constants, and interpretation function for the predicate letters. Now that we've set up a model, we can determine which sentences are true and false in our model. That's where the valuation function comes in. So the two big important things here are the interpretation function and the valuation function. The interpretation function tells you what the language means. The valuation function tells you whether things are true or false. Now, the model here up the top is just repeated from the previous slide. We're going to reason about the truth value of various sentences that we can construct in relation to the model. So, first example, we have the sentence, the forward is better at shooting threes than the center. Now, you want to look at your model and determine whether that sentence comes out true on this model. Think about how the valuation function is defined. This sentence is only going to come out true if the ordered pair consisting of the interpretation of F and the interpretation of C is a member of the set IR. So you want to look at, does this set IR here contain an ordered pair with the forward as the first entry and the center as the second entry? This would be a good time to pause the video and ask yourself, is this sentence true or false on the model? Turns out this sentence comes out true on our model. And here's the reasoning behind that. Notice that this is an atomic sentence. Right? We don't have a quantifier and we don't have a propositional connective. So we need to look at the way valuation functions work on the atomic clauses. And we know that a sentence like this is going to come out true if and only if the ordered pair consisting of the interpretation of the word forward and the interpretation of the word center is a member of our set IR. Since the interpretation of the word forward is Tucker on our model, and the interpretation of the word center on our model is Capella, this is true precisely when we have an ordered pair with Tucker as the first entry and Capella as the second entry. So we need to look at our model and say, do we have an ordered pair like that? This one is not like that. But this one is. Therefore, this sentence comes out true. Here's another atomic sentence. Again, this would be a wise time to pause the video and try to determine whether this sentence comes out true or false on the model. This is saying the center is better at shooting threes than the point guard. That means we need to look at our set IR and determine whether there's an ordered pair where the center comes first and the point guard comes second. Since center is being interpreted as Capella and point guard as Harden, we need to look for whether there's an ordered pair with Capella as the first entry and Harden as the second entry. This doesn't fit the bill, this doesn't fit the bill, and this doesn't fit the bill. So there is no such ordered pair in this set. Therefore, this sentence comes out false. More simple examples on the way. Suppose we have the members of chess club, Alice, Bob, and Claire. Suppose Alice is the president, Bob is the treasurer, and Claire is the secretary. So we have three individual constants. We have P for president, T for treasurer, and S for secretary. Now we have a one-place predicate letter, FX, and that stands for X can vote on financial matters. So some ranks in the chess club can vote on financial matters, others can't. Going to have a set that contains only the people that can vote and does not contain the people that cannot vote. So here's our model. We have a domain. We're calling that C for chess club. And then we interpret each of the constants. Then we interpret our predicate, F. Now that we have a model, we can start evaluating the truth or falsity of sentences relative to that model. So here we again have that V function. We want to know if this sentence is evaluated as true or false on the model. What this is saying is the president can vote on financial matters, and the treasurer can vote on financial matters, and the secretary cannot vote on financial matters. This would be an excellent time to pause the video and determine whether the model makes this sentence true or makes the sentence false. Turns out the sentence is true, and here's the reasoning. This example is different because it contains propositional connectives, whereas our previous examples were atomic. So we need to look at the clauses for conjunction and negation. We notice the following. In order for this sentence to be true, here's what needs to happen. The model needs to make FP true, it needs to make FT true, and it needs to make FS false. That happens just in case our interpretation of the word P is in the set IF, our interpretation of the word T is in the set IF, and our interpretation of the word S is not in the set IF. Now we look over here at our set IF, and we notice that P is Alice, so the interpretation of the word P is in the set IF. That checks out. Our interpretation of the word T is Bob, so Bob is in the set IF. That checks out. And our interpretation of the word S is Claire. Claire is not in the set IS, so that works out as well. Here's a final simple example. Suppose the members of Drama Club are Alice, Bob, and Claire. Alice is the treasurer, Bob is the president, and Claire is the secretary. So our language contains, again, these three terms, and our language is going to contain a two-place predicate letter RXY for X is better at Shakespeare than Y. Now we're going to set up our model. Our domain is the members of Drama Club, our interpretation of the individual constants. Our interpretation of the predicate R is such that Alice is better than Bob at Shakespeare, Claire is better than Bob at Shakespeare, and Alice is better than Claire at Shakespeare. Given the model, now we can determine the truth or falsity of sentences using our valuation function. Here's our sentence. There is an X such that RXP. There is someone who's better than the president at Shakespeare. Is this sentence true or false on the model? Well, what you want to do is look at the ordered pairs in R and determine whether there's an ordered pair in which there's someone first and the president is the second item. So how are we interpreting the word P? We're interpreting that as Bob. So we want to look at the set ordered pairs here and ask ourselves, is there a set in which Bob is the second item? And the answer is yes. Both of these sets satisfy it. For the existential quantifier, we only need one, but having two is fine as well. So this comes out true. Right, and here's our formalized reasoning. I just went over the reasoning informally, but here it is formalized. Note that the interpretation of treasurer is Alice, the interpretation of president is Bob, and the ordered pair consisting of Alice followed by Bob is a member of the set IR. You can see that right here. Then we have an ordered pair such that the interpretation of T and the interpretation of P is a member of IR. Then by the clause for atomics, we have RTP comes out true on the model. Then by the clause for existentials, we have at least one atomic such that this sentence comes out true. Therefore, the existentially quantified version of that sentence comes out true.